Hello, Chem 100 students. Hi, my name is Dr. Kimberly Smith, and everyone calls me Dr. Kim. I am here today to teach you about chemical formulas in your Chem 100 course. So, chemical formulas tell us how many atoms are in the chemical and what type of atoms are in the chemical. So chemical formulas do not tell us the shape of the molecule for the chemical. It doesn't tell you anything about its shape or bond angles. It also doesn't tell you the bonding order of the atoms. It just tells you how many of each atom there is in the chemical or in the molecule, but it doesn't tell you how they're bonded. Let's look at an example that most everyone knows, water. You probably already knew water's chemical formula was H2O. H2O, that's a chemical formula. It involves the element symbols with little subscript numbers that tell you how many of that atom there are. Now in H2O, what it's telling us is that we have two H hydrogen atoms. So the subscript follows the atom symbol. It's H2. The 2 goes with the H. And then we have an O. Now there's no subscript there, so it's an understood 1. It means there's just one oxygen atom there. So we don't show the 1 if it's a 1. So water again is H2O. That means there's 2 hydrogen atoms plus 1 oxygen atom makes 3 atoms total. So 3 atoms are in the water molecule. However, it doesn't tell you how they're bonded. We don't know whether it's bonded H to H to O or H to O to H. We'll learn more about that in Chem 130, but it doesn't tell you the bonding order in the formula. So now that you know what a chemical formula is and you know what the subscript numbers mean and you know that we don't write a 1 if there's only one of that element in the formula, how many atoms are in these? The first one is CH4. How many atoms are in CH4? If you said 4, you're not quite right. Don't forget the C there means there's 1. So there's 1 carbon, C for carbon, and there's 4 hydrogens, H for hydrogen. So 1 plus 4 makes 5. There are 5 atoms in CH4. What about H2SO4? You are correct if you said 7. So there's 2 hydrogen atoms, there's 1 S atom, sulfur, and 4 oxygen atoms. Don't forget that 1 for the S. So it's 2 plus 1 plus 4, which makes 7. What about Na3P? Now N and A, that's just one element, right? The lowercase a is not a different element. So it's not like there's an N and then there's an A. It's Na together. Capital letter with a lowercase letter is one element. So that's sodium, Na. There's 3 of them. Plus 1 P, phosphorus, makes a total of 4. If you said 4, you're right. Good job. 4 atoms in Na3P. What about GaCl3? That is an L, GaCl3. You're correct if you said 4. Again, there's 1 Ga atom and 3 chlorine Cl atoms. 3 plus 1 is 4. And the last one, C2H4O2. How many atoms are in that? You're correct if you said 8. Good job. So again, our answers are 5 for CH4, 7 for H2SO4, 4 in Na3P, 4 also in GaCl3, and 8 in C2H4O2. 2 plus 4 is 6 plus 2 more is 8. All right, that's not too bad, is it? How many atoms are in a chemical formula? You've got it. So let's talk about ionic compounds now. An ionic compound is made up of a metal and a non-metal. So let's go look at where the metals are in the periodic table and where the nonmetals are in the periodic table. So here's your Chem 100 table. Yay! All right, do you see right up here this darkened bold line that continues up and looks like a stair-steppy line? Well, the metals are on one side and the nonmetals are on the other side. Which side is the metals? You're correct if you said the left side. The left side is the metals of that stair-steppy line. Now, there is an exception. H, the very first element, way over there. H, hydrogen, is not a metal. I know it's on the metal side, but it's a non-metal. Okay, but everything else on that left side of the stair-steppy line is a metal. So Li, Ni, Na, K, Ca, Mg, Cu, Co, Mn, Fe, those are all metals. So where are the nonmetals? Yeah, they're above me on the right side of the stair-steppy line. There's not as many nonmetals. In fact, there's quite a few less nonmetals than metals. But carbon, C, nitrogen, N, oxygen, O, those are nonmetals. And the last column, the noble gases, helium, He, neon, Ne, argon, Ar, and so forth, the noble gases are all nonmetals. So the nonmetals are on the right side of that stair-steppy line. Now, you may have learned that if you're touching the stair-steppy line, if you have a complete side against the stair-steppy line, you're actually a semi-metal, except for aluminum. Aluminum's just a metal, right? We make cans out of it. But B, Si, Geas, Sb, Tepo, those are semi-metals. All right, so now you know where the metals are, the nonmetals, and the semi-metals. Remember, an ionic compound is made up of a metal bonded with a nonmetal. In the chemical formula, you'll see a metal and a nonmetal. And the metal's always listed first, by the way. So, ionic compounds are made up of ions. That's why it's ionic. Ions. What's an ion? Well, that just means the atom now has a charge. It's not neutral anymore. Atoms are neutral, meaning they have a zero charge. Like pure gold is neutral, zero charge. Pure oxygen gas, zero charge. But atoms can gain or lose negatively charged electrons to become more stable. And we'll explore that more in Chem 130. But an atom can gain or lose negatively charged electrons. Remember, electrons have a negative charge, -1, a -1 charge. Now, in general, metals tend to lose electrons. If you lose your negative electron, the negativity goes away. What happens to you when your negativity goes away? Well, you become a more positive person, don't you? So if you lose an electron, which is negative, you become more positive. So metals tend to lose electrons, making them positively charged ions. We call them cations. And look, there's a T in cation. So that's your plus, positive charge. So cations have a plus in it. The T is a plus. So you can remember cations are positively charged ions. They can be +1, +2, +3. That's what we're going to learn about in this lesson. Now, the nonmetals tend to gain electrons, which are negatively charged. So if you're gaining more negativity, what happens to you? Well, you become more negative. So nonmetals tend to gain electrons, which are negative, making them negatively charged ions. We call them anions, like the anode of a battery is the negative part of the battery. Anions. And so nonmetals can be -1, -2, -3 charged. And we're going to learn about that today. So again, the important thing to remember here is that ions are when the atom has a charge. like +1, -2, +3, something like that. So ionic charges. We're going to learn, again, more in Chem 130 about how and why these atoms gain and lose electrons and become cations and anions. Now remember, atoms are always neutral with zero charge for an atom, which is the element in its natural occurring state, like solid gold, solid copper, gaseous oxygen, neutral. But we're going to learn some of the ionic charges. Once the atoms become ions, they have a charge. We're going to look at some of the main group elements, ionic charges. So ionic charges, metals, again, they lose electrons and become positively charged cations. Column 1A in the periodic table, those metals have a charge of +1. It's because they lose one electron, but we'll focus on that more in Chem 130. Column 2A has an ionic charge of +2. And column 3A has an ionic charge of +3. So when these metals have lost their electrons, the first column is +1, the second column is +2, and the third column is +3. Let's look. Our first column, not hydrogen, because that's not a metal, but Li, lithium down, those have an ionic charge of +1. Column 2A, Be, Mg, Can down, those have a charge of +2. Now column 3 is over here, closer to me. Column 3A starts with B for boron, and then Al, aluminum, is a metal. Aluminum on down has a charge of +3 when it's an ion. So I would get out your periodic table and literally write at the top of column 1A +1, the top of column 2A +2, and the top of over here, this column 3A, the aluminum column, +3. All right, let's go back to the nonmetals. The nonmetals gain electrons, okay, so they become more negative, so they become anions. Column 5A has an ionic charge of -3 or -3. Column 6A has an ionic charge of -2. And column 7A has an ionic charge of -1. Let's look at these on the table. Okay, so right above me, column 5A, the one with N nitrogen and P phosphorus, those are -3 charge. Put a little -3 on top of that column. Column 6A, 6A, the oxygen column, O, S, and Se, those have a charge of -2. So put a little -2 above that column. And then finally, column 7A with F and Cl for fluorine and chlorine and bromine and iodine. That column has a -1 ionic charge. So put a little -1 above that column. Excellent. So now that your periodic table is labeled, let's look at the ionic charge of these atoms when they become ions. So when K, which is potassium, becomes an ion, what is its charge? Find it in the table. It's in the first column, isn't it? Column 1A. So that means it's +1. What about Mg? Did you find it? It's in column 2A, right? So that means it's a +2. What about Br? Bromine, Br. All right, it is in column 7A, 7A. So its ionic charge is -1. What about oxygen? Find it. Yeah, oxygen is in column 6A, so it has a ionic charge of -2. What about aluminum? Did you find it in column 3A? That means it has an ionic charge of +3. And the last one, nitrogen. Do you see it in column 5A? That means it has an ionic charge of -3. Yeah, so it depends on the column. Now, the other columns, we're not going to worry about in Chem 100. We're only going to worry about those 6 columns. So we're only going to worry about those metals in columns 1, 2, and 3A, and the non-metals in columns 5, 6, and 7A. That's all we're going to worry about in this class. Don't worry about the other columns. All right, you did a great job. Now we have some questions for you. I hope you enjoyed this lesson. See you soon. Bye-bye.